Hello, this is Alicia Henn from Biospherics, and today we're covering Unit 6, important tips and tricks that we want you to know to help speed your way up the learning curve. We're going to start with talking about Xvivo system data. Now, there are two file types that you need to know about. There are .hst files and .csv files. Now, the .hst files, these are history files. They're used only by the Xvivo system software to record all of its sensor data and all of the modules, and it's recorded continuously. Now, this data is not usable for analysis outside the Xvivo system software. It's important, though, to have backups of it because it is particularly useful for recovery of all the Xvivo system sensor data should there be a catastrophic loss of your computer. So it's important to back these up regularly. We like to back them up weekly because we figure that, a week's worth of data, we don't want to lose more than that should there be a catastrophic computer issue. .csv files are what we are able to export out of the Xvivo system in order to be able to use it for analysis in other programs. So it's important to also export your Xvivo system data if you want to be able to use it for, say, adding to the batch record of your cells or tissues that you're producing in the Xvivo system, or say, presenting to other people. You want to be able to show it off, or for, just general lab records. Anything you need to use the Xvivo sensor data for, you need to export it. And we'll export data after a big experiment, after a big product run, or we'll do it at weekly intervals. We don't like to let it go longer than about a week before exporting this data. So the HST files are very highly compressed. The CSV files can get very large upon export, and it can get so large that it'll freeze up your computer. So you need to balance the number of days or hours that you're exporting with the frequency of time points that you're exporting. So if 60 seconds is okay for the granularity you're looking for, a week is not unreasonable to export at a time. If you really need 5-second granularity on the environmental data and the sensor data in the Xvivo, then you might want to do a day at a time rather than a whole week at a time. It's up to you and what you need out of that data as far as balancing the number of days that you're exporting with the frequency of the time points. So planning. Now, those of you coming to the Xvivo system training from a GMP environment will understand what I mean when I say planning is your superpower. For those of you that are coming from a more academic environment that are working toward GMP, this is something you're going to need to learn and to integrate into your daily work life. Now, we like to plan each process in the Xvivo system like a trip to the moon, like a moon mission, because it's super frustrating to be in the middle of your process and need one more thing. You have to take your hands out of the sleeves, you have to get up out of the chair, go find that thing, disinfect it, let it dry, get it into the Xvivo system through the log dilution ventilation. And we have had people that have gotten so frustrated because they didn't plan well that they have actually breached the system in order to just throw things in there and work with them. And, we don't want you to experience this frustration. And the key is really having a good plan. So if you plan your process, we have found that every process takes this sort of general shape. First of all, you have your setup. You have your disinfected non-perishables that can go into the Xvivo system. They can even go in the night before. Get them all set up. Things like flasks, things like pipettes, things like other materials that are not temperature sensitive. And the nice thing about putting them into the Xvivo system early is that if you're working in physiologically relevant oxygen levels, all of these items can equilibrate to the proper oxygen level before you work with them the next day. So we'd encourage you to get those set up the day before process. Then before you perform your process, you send in the perishables. You send in your temperature sensitive items, whether this is like a bottle of medium that's been warmed in an incubator. You might want to send that in the night before if you want that to equilibrate to the proper oxygen level as well. But if you don't need to, then send that in just before you do your process, or a vial of frozen cells, maybe something like that. Then you perform your process, and as you finish with each item, place it in a tray in the buffer chamber ready to exit, but don't take it out yet. What you want to do is wait until, if you can, if you don't have too much materials built up, you want to wait until your cells are in the incubation chamber or they are out the product exit, whatever they're doing in your process, and everything's closed up, and then bring all your waste out together. At this point, you want to gather any remaining waste that's still in your process chamber, you know, whether this is bags of dry waste or bottles of liquid waste or unused items, and place them all in that exit buffer chamber in the tray. Then you do your post-process disinfection, working from the end of the Xvivo system that is farthest away from your exit buffer through the modules all the way until you get to your exit buffer. Then you can take your disinfection items and put them on that the tray with everything else coming out of the Xvivo system, close the door, and everything comes out together. Then you do your log dilution ventilation of that exit buffer chamber. So that is the most efficient way to do your process. Bring everything in together, bring everything out together. Unless, of course, you have, you know, very large overwraps of things, or you have a lot of other waste that means you're going to need to process your exit buffer chamber several times, then of course bring those out as you need to. But before you open your exit buffer chamber into the process chamber again, of course you're going to need to run your log dilution ventilation to replace the gases in there before you open up that inner door again. Now, this is the SOP template. This is something that can really help you plan your process. So like you saw in that general plan I just had on the previous slide, in order to be able to perform the post-process disinfection without bringing more items in order to do that, I need to have them in place when I start the process at the beginning. This is the most efficient way to do it. Now, this Excel workbook that we use for the SOP template doesn't look like much, but actually it's a powerful tool for planning out your process. A lot of you may have seen this already when we first planned your Xvivo system, because this is very helpful for us to engineer the proper environment that you need around each step in your process. Actually build your Xvivo system from the process out. But you can use this as well to plan your SOPs for working in the Xvivo system. So we encourage you to keep using it. Fill out this SOP template with just as much detail as you possibly can, right down to the right hand does this in this step and the left hand does this. This will make sure you don't miss anything that you're going to need inside the Xvivo system for your process. So let's go across the top of this spreadsheet. We have the step number, we have the module number, that's where it's happening in the Xvivo system. We have whether that step is open or closed as far as the risk to the cells or medium. We have a description of the step. We have co-supplies, and we would use this for, say if you had consumables that would travel with your sample through the Xvivo, you'd want to put them there. Pre-supplies would be something that could be pre-placed in the module, like a box of tips. And then you have equipment, that's self-explanatory, any waste that's generated in that step. And waste is important to plan for in your Xvivo, which you may not be used to if you're only used to working in a biological safety cabinet. Then we have columns for module pre-prep and post-prep. And pre-prep might be something that you need to do inside the module ahead of time in order to prepare for that step, like chilling a chill chamber. And post-prep tends to be cleanup steps. And then the time that step takes is important to put there as well. That will help you plan. Now, as you fill out each step in this sheet, you'll place things that you need for that step in the first import step. So this literally gathers up your kit for that process all in one place. Now, we highly recommend working with kits of materials. These are non-perishable items that can be assembled ahead of time with a few extras in case you need an extra pipette or extra flask. Let's talk about importing items. Now, when you import items, it's important to push them all the way to the far door in the buffer chamber before you shut the door and do your log dilution ventilation. This will make it much easier to reach things out from the other side. And we have found it quite helpful to use trays when you're bringing in lots of items, particularly small items, into the Xvivo system. So if you have a little, 1.5 mil epi and it falls out of a rack and you're not fishing around in the buffer chamber trying to reach that out from the other side, it's in a tray and you can pull the whole tray out and reach everything that you have in the chamber. Now, if you do use a tray, make sure to check that the underside is perfectly smooth. You don't have any sharp little plastic bits or little feet that are scratching the floors in the buffer chambers. You don't want to scratch up the floors. So with all the data that you're gathering from the Xvivo system sensors around your process as you practice it, you can also optimize other parameters so you know what to set them to for your process. Now let's talk about relative humidity first. Now the Xvivo system obviously isn't plumbed to your water pipes. It's not adding humidity to the air. The only humidity that it gets in there is from the water you bring into the system and any processing fluids you bring into the system. But if you put a ton of water into an incubator, say if you fill up that tray that's in the bottom of the incubator, that Xvivo will be fighting it the whole way to keep it down under the limit control. And it will fight it until it runs out of gas. And then the filters will get saturated with water and the sensors won't be able to read properly anymore because the RH has gone too high. So you don't want to set up that battle in there. You don't want to saturate those sensors. And again, if you do end up saturating a sensor, it's not the end of the world. Just give us a shout and we'll help you walk you through drying that out. Now, having RH that's too high can also set up a situation where you can get condensation on the inside of the Xvivo chamber. And then you're going to need to do a big clean because it's a contamination risk to have beads of water all over the place. And that will trigger a big disinfection and that will increase fume risks to your process. So you have to change out all the gases and you don't want to do that. So if you keep the humidity under control, you can limit this kind of risk to your process. So again, we recommend incubation chambers at 65% RH and processing chambers at 50% RH. So it's a good idea to optimize how much water you're bringing in to increase the humidity in your incubation chambers. What we suggest is that you start off with one little culture dish with sterile water and see how long that takes to evaporate. Does that last in between times that you need to be doing your cell process handling or cell handling or cell passaging or whatever you do with those cells? If one dish goes dry from, between processing days, then add a second dish. And you can add a third dish if you need to, but honestly, we don't usually seem to even need 3 dishes in an incubation chamber. But there are a lot of different factors that can affect that. We'll go through in a minute. You want to make sure to remove that water from the incubation chamber if for any reason you need to turn off the RH control. I've seen it happen in labs where someone took the cells out of the incubation chamber and they left the water in there. They forgot about the water. And then a day later they see, oh, all the controls still on the incubation chamber. Well, I don't need that anymore because my cells are out of there. So I'll just turn off the controls there. And now there's still water left inside. And then the next day they come in and the sensor is saturated and they've gone through all their gases and they've got a problem. So make sure to remove the water if you're taking your cells out for any length of time, if you're turning off the heat, or if you might turn off the RH control. Don't forget about that dish of water in there and leave it in there. Just take it out. So factors that can influence your rate of water consumption include the size of the incubation chamber. They include the oxygen setting. We have found that when we have an Xvivo system with multiple incubation chambers on it and we have different oxygen levels, that the one with the lowest oxygen level will tend to dry out a little faster than ones that have higher oxygen levels. And we assume that's because there's a higher gas exchange rate in those chambers. And of course, every time you bring in dry gas, you're gonna use more water to keep the humidity up. The number of vessels that you have in a particular incubation chamber can increase the amount of liquid in the chamber, and that can change your evaporation rate. Also, whether you've got a filtered lid on there or not, whether it allows evaporation, can change your evaporation rate of the water. And definitely the number of times that that incubation chamber door is opened into the drier processing chamber can influence how quickly that little dish evaporates. So this is really something that you need to test out yourself for your own process, your own gas levels, and your own vessel types and all of that. So let's talk about oxygen, optimizing gas settings. Now, this is a frequent question I get from customers. Now, I can set my oxygen to anything I want now. It's the first time I've been able to do that. What should I set it to? Well, I'll tell you one number that does not make sense at all for anybody's process is 21% oxygen, which is the first thing you might think of. You think, well, I want to set it to be the same as my room air incubator, and room air oxygen should be about 21%, so I'll set it for 21%. But even room air incubators aren't at 21% oxygen. They really can't be. If you're adding all that CO2, you're adding 5% CO2, and you're adding a lot of water vapor, you've got 90, 100% humidity in there, you can only get up to about, I think it's calculated to be 18.6% oxygen you've got left in that gas space for the oxygen. So we did some tests where we actually took an oxygen sensor and set it in room air incubator, and we did this in several different labs in different cities across upstate New York to see what the actual oxygen level is inside an incubator. And what we found is that if we open the door, set the sensor inside, close the door, and then open it again and close it again, as if we took a flask of cells out and then a few minutes later put it back in. These are the readings that we got. We got about 17.2% oxygen in an incubator. And if we left the sensor in there for long periods of time, if we left it in there for, say, over a weekend, after 2-3 days, we would get close to that 18.6% that's calculated what the oxygen should be in there. So if you're looking to set your whole Xvivo system to the same conditions as you have in a room air incubator, I'd suggest 18% oxygen. That's what we use to mimic room air conditions in our Xvivo system when we want to use room air incubation conditions with 5% CO2 as well. Now, I would encourage you, though, however, to think about using physiologically relevant oxygen, because 18% oxygen is far, far higher than any cell inside the body is going to experience on a regular basis. If you think about it, like even the lungs, when even the airways, when you breathe air in, that air is already mixing with air that you're exhaling. So even in the airways, the oxygen level is lower than you find in room air. Even the skin, all the skin, the cornea on your eyes, all the exterior surfaces of the body, all those cells are dead. They're not, the live cells underneath your skin are getting their oxygen from the blood circulation. And so even in the skin, oxygen levels are far lower than you would expect in room air. And we have had a lot of customers find a tremendous benefit to their cells and tissues by using physiologically relevant oxygen levels constantly throughout their whole process, start to finish. This is one paper that was published recently by one group showing the benefit to their cardiac-derived cells when they used physiologically relevant oxygen throughout their entire process, start to finish. And I have lots of other data and papers on physiologically relevant oxygen levels for cells, different cell types through the body. So if you're interested, let me know. I can, I'd be happy to search my database for conditions that might be better for your particular cell type. Let's talk about chairs for a minute. Now, every person has a different body shape and size, obviously, and so different people are going to be comfortable working at the Xvivo system in different ways. Tall people tend to be a lot more comfortable sitting down, get your arms closer to that work surface. And sometimes shorter people are more comfortable standing, particularly if they have to do a lot of reaching into incubation chambers or reaching into neighboring buffer chambers. But if you have to work in the same sleeves for an extended period of time, it's important to be able to sit down. If you need to look at a microscope, it's important to be able to sit down. It just depends upon your body, and it depends upon your process, what you choose to do. Now, if you do want to sit down at the Xvivo system, it's a good idea to sit down first and get your body situated in the chair first before you put your hands in the sleeves. Because you don't want to do like I always do, which is I get my hands in the sleeves, I get over-gloved, I get everything set up in the processing chamber, and then I look around for the chair. And the chair is usually 3 feet behind me, and now I'm trying to reach with one toe to grab that chair and get it close enough to me so I can sit down. And yeah, that's not the way to go. Sit down first, get yourself all situated in the chair, then put your hands in the sleeves. And when you do get yourself situated in the chair, I'm going to encourage you to try going lower than you normally are used to at a bench or at a table. Obviously, you need to be able to fit your knees under the edge of the processing chamber. But if you set that chair really low, you might be able to get your body even closer to the chamber than you're used to. And this lets actually the system sleeves support some of the weight of your arms and makes it so that you can relax your shoulders more, relax your neck more, relax your upper back, and be able to work more comfortably for extended periods of time in the processing chamber. And don't be afraid to lean right into that glove front to reach things. It's soft and a little stretchy, but it's quite tough. This particular glove front has been in use daily for almost 8 years now. And here you see Dr. Yan He, who's a small woman, being able to easily open up the incubation chamber door and be able to grab an incubator shelf. And something else that you're going to have to get used to is pulling those shelves out of the incubation chambers in order to reach your vessels off of there. That might be something that you do more often in the Xvivo system than you would in, say, a room air CO2 incubator. You're going to be sliding those shelves out in order to get your vessels off of them. All right, now it takes time to get out of the chair, get your hands out of the sleeves, go find something in the room, get it into the Xvivo system, or move things around from chamber to chamber. Those of you that are working in the GMP world are used to having a second person in the room that's doing things like documenting your actions inside the Xvivo. Those of you that are coming from an academic world, I'm going to encourage you to have a second person in the room to handle all the materials in the room or in other chambers in the Xvivo, so that person sitting at the processing chamber doesn't have to get up and go do everything. This will save you a lot of time. Oh, but let me go back and say, notice this person's kind of hunched up at the Xvivo processing chamber. If they set their chair just a few inches lower, they might be able to sit a little straighter and get their body closer to that glove front for more comfort. Let's talk about workspace layout. This is a photo of a 47-inch processing chamber, and it has some typical cell culture processing items laid out in it. Now, as you work with things in a biological safety cabinet, you learn to put things for your right hand on the right-hand side, things for your left hand on the left-hand side. But things might be a little different when you're working in Xvivo system, particularly if you have gloves on both sides. Now, these are the same items laid out in a 57-inch processing chamber. First of all, you see you've got a lot more room. But also, if you have someone working across from you, you may want to refigure your layout so that both of you can reach things that are important for you and you both have good workspace. Plan for door swing. Now, in a biological safety cabinet, you don't have to worry about doors, but in the Xvivo system, you're going to have doors that are going to have to be opened at some point during your process, whether that is into a neighboring buffer chamber or into an incubation chamber. So you're going to need to plan for door swing when you lay out your workspace. You might consider using a small tray to contain a lot of small items if you're going to anticipate that you're going to need to move them in order to do something like open up a door. So that's just one tip that might help you avoid frustration from having to move things around frequently during your process. Now, the glove cuff is something that's new to you, and it's likely to touch things. It is a probable risk surface. If you're working for long periods of time, particularly if you're standing up, that glove cuff and the glove material will work its way down your arm and may end up sort of laying on your thumbs. And we have a quick maneuver that we'll show you during our live session for getting that sleeve material up higher on your arm and getting it up off your thumbs. But you might want to think about that at other times too, just trying to keep that sleeve material up higher on your arms and keep that cup off your hands while you're working, particularly for people that have shorter arms like me. Temperature controlled items. This is a frequent question we've got. What do I do if I've got a warmed 37-degree process chamber and I just need one tube of cytokines that needs to be kept cold? Well, you can't bring ice or dry ice into the Xvivo system. Those represent a contamination risk. So you need to have other temperature control in use. This is what we use in our lab. We like to use chilled aluminum beads from aluminum bead bath, and we soak those in disinfectant and let them dry in the laminar flow hood, and then pack them into bags that we keep in the freezer. And when we need them, we'll take the bags out of the freezer, we'll disinfect the surface of the bags, and then bring the whole bag in. And we'll keep it in a container like this, where we can tuck a single tube of something that needs to be chilled. Now, if you want to thaw cells inside the Xvivo system, and we encourage you to do so, one particularly good technology to use for this is the ThawStar system. This is a system that has a electronic thawing device. It's kind of like a little cell toaster that can go inside your Xvivo, so you can thaw your cells under completely controlled conditions. And it also has a little holder, like a little metal holder, that can go into your freezer, and that can keep your cells cold in this little foam insulator while the cells are being imported through the log dilution ventilation process. And all of these can be disinfected. So it makes it a particularly good system to combine with your Xvivo for keeping cells frozen all the way until they get inside the system and then thawing them in place. And this would replace, say, a water bath where you'd be thawing the cells outside in the water bath and then having to disinfect the cells and having to put them through the log dilution ventilation in a thawed state where they're sitting there in cryoprotectant. We're trying to avoid that. So this system gets rid of that extra time that the cells are sitting in cryoprotectant trying to get into the Xvivo system. Now, this is another frequent question we get. What can we clean the nose prints off the glove front with? What can we clean the outside of the Xvivo system in our clean room? Well, generally, you can use any disinfectant that you routinely use in your clean room or lab. And this is a great place to use all those alcohol wipes that you're not using inside the Xvivo system. Use them for cleaning the nose prints off the outside or doing your routine cleaning outside. Oh, I will say before I leave this that we did have one person a customer that came to work in our Xvivo showrooms once that wore heavy makeup. Now, you can't wear makeup in a clean room, but she wore makeup to come work here, and by the end of a workday, the Xvivo system glove front was wearing a lot of that makeup. So, and people are people, and people sneeze, and they don't want to share germs with the next person that's going to come work in that system. So please feel free to clean the outside of that glove front frequently with alcohol or another convenient disinfectant. When should I call you? This is a great question for new parents, whether they've got a new baby or whether they've got a new Xvivo system. You should call us right away about something that indicates there's a pressure problem in the Xvivo system. Something like if you came in the morning and you found the gloves all inflated and standing out, and that's not normal unless you're actively doing a leak test. If you come in and you see that the glove front is kind of sucked in and it looks like there's negative pressure inside the chamber, then call us right away. It could be something's going on with your pump, or well, we can help figure out exactly what's going on with the pressure in that chamber. If you accidentally water saturate a sensor and you don't know how to dry out the sensors, give us a shout. We're happy to walk you through that. If there are any temperature control problems, it seems like the chamber floor is having trouble keeping a temperature up to 37, please give us a call. If you have any large negative process values, like your sensor is turned on, the controller is turned on, but it's still reading negative 88,000 something, give us a call. We're going to want to troubleshoot what's going on with that particular sensor. Give us a call if you have any alarms that you don't know how to address. And of course, give us a call with any other questions or issues that come up. It's important for us to be able to address any issues before they become a frustration for you. We don't want you to experience that. So, give us a shout, let us know what's going on. We're happy to help. For equipment questions, please give service a call. Here's a phone number here. They always have someone on call that will answer that number. For any cell or process questions, shoot me an email and me or someone on my team will get back to you right away. If you have a question that pertains to a regulatory issue, I'd be happy to forward that to our regulatory team. So we want to hear from you before you get frustrated with anything so we can help. Thank you, and I look forward to talking with you more on our live session. Thanks very much. Bye.